Welcome to Unit 8, Note 7, the distance formula. This is your host, Mr. Hoopert. We are learning how to target the distance formula and apply it in fabulous math problems. So without further ado, we have a certain helicopter can fly 450 miles before it needs to refuel. Suppose a person needs to be flown from a hospital in Minneapolis to one in Chicago. Chicago is 225 miles east and 175 miles south of returning. Can the helicopter make the trip one way without refueling? Now, this is a great problem because with our formulas, we know this is a right angle. So this is one of those problems that I would do that thing called the Pythagorean theorem. So I'd probably come over here, I'd go, hey, I had 175 squared plus 225 squared, and that's going to equal that c squared, or the hypotenuse, right? This is your c. Now, the beautiful part about that is your little compass thing. Never eat, I said eat, wrote a W. That's funny. Never eat soggy waffles, right? This compass is always a right angle in the middle. So anytime you have directions, you can do Pythagorean theorem. So I'll switch back to my yellow. 175 squared is 30625. 225 squared. I actually had that value today in math class and geometry, but whatever. 50,625 equals c squared. Well, then you get this awesome value of 81250 equals c squared. Opposite of a square is a square root. So to figure this out, we added that square root, second answer, you get 285 miles. 285 points. All right, let's do this correctly. I would have said you get 285.04. So I would have said, okay, this question mark needs to be about 285 miles. Well, when I read this problem, for a helicopter can fly 450 miles before it needs to refuel, we have like 150 miles to spare, more than. So can it make the trip one way without refueling? Yes, it can make the trip. Nice sentence, Hooper. All right. So here's what we're getting to. With compasses, you can do this stuff. All right, because it's a 90-degree angle, it has perpendicular written all over it. Now the other thing is that we have points here that we would need to calculate. We have this fantastic thing called the x and y axis. And what it allows us to do is it allows us to do this distance formula. So you have this xy axis. So this is 1, 2, 3, 2, 1. So if Minneapolis would have been up here and Chicago is down here, we now have the ability to calculate it. This could have been -2, 3. This could have been 3, -3. Right? And now we have x's, we have y's, and we have this formula. This is the distance formula. You subtract the value of the x's, square it, add it to the values of y's. Now, quick thing to note, this is being squared, so it's going to be a positive answer. Alright, so if you have -3 squared, that's a positive 9. Negative times a negative is positive. If you have 3 squared, it's a positive 9. So it doesn't matter what order you do the subtracting is. Just make sure you have the x's grouped together in subtracting and the y's grouped together in subtracting. So we'll look at this. I don't know what this going the distance thing is for, but it's kind of cool. All right, find the distance between the points given. If necessary, write your answer as a simplified radical. This right here needs to ring a bell that we are not rounding ever. These are exact distances. So if I look at this, this would be my x1, y1. That's my first point I'm going to use. This is my second point. So that distance formula, I didn't tell you really what it is, but it's going to be the square root And I always write it as x2 minus x1 squared plus y2 minus y1 squared. So when I actually do that, I would go distance is equal to square root 11 just going to be square root 11 minus 5 is 6 squared plus 7 minus a negative 1 is going to become a plus, so it's going to be an 8 squared. 6 squared is 36 plus 64, and then when I do that, I'm going to have square root of 100, which we should know is 10. So the distance between these 2 points is miraculously a value of 10. So that's pretty cool. That's what we're just ultimately going to do. So your quiz and test, you're going to have one regular one, two regular ones, and one word problem. So when we look at this, I would have said, hey, I got an x1, y1, x2, y2. So we subtract the x's. So I probably would have wrote negative 4 minus 4. Then I would have said plus, and I see that we need to subtract y's now and square it. So the y's, I did negative 4 first. So I actually made this my 2's and this my 1's. It does not matter as long as I have my y's together. So 2 and 17. So I'm going to do 2 minus 17. Just make sure you have the correct numbers together. So when I do this, negative value here. If you put negative 8 in your calculator like this, it is going to equal negative 64. If you put negative 8 in your calculator like this, it is going to equal positive 64. Somewhere you need to know in your brain cells that this is the correct answer every time. Negative 8 squared is not negative 64. It's operator error if you get it wrong. So this is going to be 64 plus 225 square root 289. Square root of 289 is a nice 17. So this is how we do these, all right? So you're working a lot with some negative numbers and subtracting things. Nothing that should be confusing for you. So we're going to go the distance, and I'm going to just do that. So our formula is this nice thing where we subtract the x's. Square it, add it, subtract the y's, squared. So I look at this one, 2, 3, negative 4, 6. The x's are 2 and negative 4. So I would have said 2 minus a negative 4. And I would have squared it. This is all square root plus. Now I did the 2 first here, so then for the y's I would have to do 3 and 6. But I have to do the 3 first. Alright? 2, 3 was the second point, so that's why 2 and 3 are first. Negative 4 and 6 were the first point, that's why they're both minus. 2 minus a negative 4 is plus, so I have 6 squared plus 3 minus negative 6 is negative 3 squared. Notice I write the parentheses because there's no excuse for you not getting this right. Negative 3 squared is a positive 9. So we got 36 plus 9. On top, it says right as a radical. So this is square root 45. That is also equal to the square root of 9 times 5. And the square root of 9 is a nice whole value that I know, which is 3 square root 5. So you are capable of solving this correctly for 3. Right? Note that you have to leave it as a radical. Alright, this last one. So x1, y1, x2, y2. So when I do that, I'd have negative 2 minus 4. Square it. Plus. I did negative 2 first, so I gotta go with the y2, which is negative 5, minus a negative 1 squared. And I am going to go like that. Negative 2 minus 4 is negative 6 squared plus negative 5 minus a negative 1 would be plus. So negative 5, it goes 1 degree warmer, is negative 4. Square root. Remember, if you're not listening to my video and you get these wrong, I might make fun of you. You have the ability to know negative times a negative is a positive 36 plus a positive 16. Good news, 36 plus 16 is 52, which actually, the only number I know that goes into it is 4 and 13, which eventually you would have got to square root 4 times the square root of 13. Sorry, that looks funny, but square root of 4 times square root of 13. That's what I'm looking for you to be able to do. That is a lot of formulas to remember, but you have the ability to do it because you're getting good with using numbers at the end of Unit 8. So let's try these word problems. Tracy's golf ball is 20 feet short and 8 feet to the right of the first putt. The ball lands 2 feet to the left and 3 feet beyond the cup. The ball went in a straight line. How far did it go? Here's what I would do. Alright? You need to know we can do this as left and this is right. So then what I would have, 20 feet short would be a Y position and 8 feet to the right of the cup. So what I would have done is I would have counted out here. To the right, 8. We'll make that 8 and Y 20 down here. So this point here is 8 comma negative 20. Now the negative 20 comes from knowing that these are negative and these are positive values of Y. The negatives over here and the positive values of X are there. So short is going to be less than. So I went down. Now it says the ball lands 2 feet to the left. So I'm going to go 1, 2, and 3 feet beyond the cup. So just right here. So this ball went 2, 3. So I actually centered the cup here. This is the cup. This is what the black writing represents where she was before she shot. The blue writing represents where she is compared to the cup. Now I made one mistake here. This is a negative 2. This would need a negative 2. So when you do this stuff, right is to the right is positive, left is to negative to the left, and then you have to remember that you can do distance formulas with these values. So I probably would have came here and I would have said, alright, well this is the first point they gave me. This is the second point. So that's why I do x1 and x2. So then my formula was this big long thing. It said x2 minus x1 is y2 minus y1 squared. If you didn't rewrite that, that's fine, but you have to know how to use it. So x2 is going to be the negative 2 minus the 8 squared plus y2 is going to be the 3 minus the 20, and you're squaring that. So I would have said distance is equal to negative 2 minus 8 is going to be negative 10 squared, and then this one is 3 minus 20 is negative 17 squared. Now negatives and negatives happens to be a negative 20, so that becomes a plus, so this is actually 23. Good catch on my own. Good thing I don't have to record this notes video. It wouldn't matter, I'd just make you erase anyways. So, negative 10 square root, that is 100. Positive 100, nobody should get that wrong. This is plus 529. So when you do 100 plus 529, that is actually 629. And now, 629 square root. What? I know what I did wrong. Don't ask me. Alright, so this is 25.1, approximately. Now here's what I'm going to do. I'm going to say that I hit the ball 25.1 feet because that's something we can relate to. Alright? You don't tell mom, hey, drive me square root 629 miles to McDonald's. she'd look at you and go, what? That doesn't even make sense. How far am I going? Right? So communication, hey, I hit that ball about 25 feet. So use the golf problem to get you interested, application, but most people aren't going to do it. Golf does use this grid stuff. All right? They grid out the maps and things like that. That's how they calculate how far stuff is all the time. So on her college campus, Kelly has her first class in Rhodes Hall and her second class in Fulton Lab. How far does she have to walk between her first and second class? So what you should look at and get good at doing is apparently fractions. Yikes. No, I'm just kidding. I'm not going to make us do it that way. What you should be good at is calculating some of this stuff together. So I look at this. I am so confused by this problem. Why don't we just add it up? I'm going to. I'm voting that how far does she have to walk between her first and second classes? Well, I would argue it's a quarter mile plus 3/8 of a mile and plus 1/8 of a mile. Well, I would see that this one is the only one without a common denominator. I would multiply top and bottom by 2 because 4 times 2 is 8. So 2/8 plus 3/8 plus 6/8 plus 1/8. And if you're really good at math, what you do is if I have 2 slices out of 8 and 3 slices out of 8 and 1 slice out of 8, we get 6/8 of a mile, which is actually 3/4 of a mile. So she's got to walk 3/4 of a mile between her classes. That's pretty cool. Now I should read this a little bit close. Her first class and her second class. So she does 3/4 of a mile walking. I don't really care. This one is actually going to become a really cool problem regarding Pythagorean theorem. So what it actually says, her first class is in Rhodes Hall. Boom, right here. And her second class is down here in Fulton Lab. So how far is this from this? So what I would have done is probably actually 1/4 of a mile plus 1/8 of a mile. Tells me that her whole distance, this blue line, is 3/8 of a mile. Then I would say, hey, this one was 3/8 as well. Something must be going on there. But I would do Pythagorean theorem with this one because they didn't give me any values. It's not on a grid. So I see that the two sides are 3/8, and that has to equal x hypotenuse squared. Sometimes I just label my x squared as my unknown. So 3/8 and 3/8, you should be good at this. 3 squared is 9, 8 squared is 64, plus 9 and 64 equals c squared. If I look at that, these are common denominators already, so I have 18 over 64 is equal to c squared. Now this is good for me because I know a lot about math, and I know that I want to square root everything. So what I would have done, and you did it on your last test, is square root some of this stuff. So I would argue that this is square root 18 over 8 is equal to c. Now the square root of 18, I would prefer if I wrote it as square root 9 square root 2. Because what I do with that is I change that to 3 square root 2. So if I change square root 18 to 3 square root 2, I'd have 3 square root 2 over 8 equals c. And that's what I would do. Now, in the end, I would probably look at that and go, that doesn't mean anything to me. I don't actually understand how far I walked. So I'd probably put square root 2 in the calculator. I'd times it by 3, divide it by 8. I would find out that I approximately walked 0.53 of a mile. Right? So they could give it to me in fractions. You should leave it in fractions. But I like distance being in miles when you're talking miles. A lot of people are going to do that problem way differently. Sorry I screwed up, but that's how life is. Good thing we remember how to do Good thing we know how to do fractions. So what they're talking about is the derivation of the distance formula. Basically what they want you to know is, let's make this easy. So we'll go 6. So this is, let's use 6 comma 0. Right, then we'll go up here, we'll use 0 comma 8. Right, so what I would do is I come over here and I would do the x's. So it'd be 6 minus 0. And since I used the 6 first, I'd have to use the 0 next minus the 8 up top squared. Then you'd have 6 squared plus negative 8 squared. And then you'd square root that. And you'd have 36 plus 64. And you get the square root of 100. Well, that's 10. Okay. Now the other thing you could do is you could count this one. This is 8. It's up 8. It's over 6. So really what I have to figure out this problem is this kind of combination of 6 squared plus 8 squared equals x squared. I'm just labeling it x because I do that a lot. Then I'd have 36 plus 64 equals x squared, and 100 equals x squared. So there's a combination of algebra and Pythagorean theorem, which is geometry, that goes together. You have 10 and you have 10. So if you relate all these points back to the center, you can just do Pythagorean theorem, which was last notes. Or the way they came up with this was they said, hey, I know that the difference in x and the difference in y is going to added together and square rooted. So when they talk about the distance in x and the distance in y, what I'm telling you is x2 minus x1. That's the difference in those, right? That's how much they change. And you add it to the difference in y's, that's a parentheses square root. If you square those values and then square root them, we are going to end up with the same answer. So we have a lot of things that go hand in hand, and distance formula and Pythagorean theorem have the same ways to do it. So find the possible values of A if the distance between the points 7, 5, and A3 is 10 units. So what I would do there is I would say, these are some fun problems, by the way. I need the x's. So A minus 7 squared plus, right, we would have A is with the negative 3, so I got to use that again first. Negative 3 squared minus 5 is going to equal 10. Well, what's the opposite of the square root? It's to square it. Right? So now I have A minus 7 squared plus negative 8 squared equals 10 squared. I would leave this as A minus 7 squared plus 64 equals 100. Subtract 64. Subtract 64. And I have this awesome stuff. This is A minus 7 times A minus 7 squared, blah, blah, blah. You don't need to find that. We have A minus 7 squared equal to 36. Why I love this problem is you should see here. To get the A by itself, I would square root that. Alright? And to get that, A minus 7 is going to be equal to 6. You add 7 to both sides, and you would see A is equal to 13. Alright? So there is some fun possible combinations to solve for some math there. Just take some algebra if they give you 2 points. Alright? The other thing you could have done here is some problems like this. Now this one's a little bit trickier. They gave you square root 58. Now that's actually trickier is not the correct word for that. Because I would have said 3 minus a negative 4. Squared it. Plus A minus 5. Squared. is equal to the square root of 58. So what I would like you to do, to get rid of the square roots, you have to square both sides. So just because it looked like a bad value, square root of 58 actually turned out just to be 58. Alright, 3 minus negative 4 is going to be 7 squared, plus a minus 5 squared. 7 squared is actually 49, so I'm going to get rid of this 7 squared. If you're listening, you understand that's 49. So I subtract 49, we have this value of a minus 5 square root. 58 minus 49 is 9. Now this is the step where you can square root both sides, and you're going to get a minus 5 equal to 3. You're going to add 5 to both sides, and 3 plus 5 is 8. So the deriving that formula is it's just kind of the distance formula backwards, or however you would like to talk about it. So we need to make sure that we're communicating with other things. Alright, that's all for the notes. Alright, those last couple problems there, it's pretty heavy level math, but we should be able to work forwards and backwards with different equations. Alright, thank you very much. Have a good day.